Welcome back to Leetcode. Let me know what kind of tea you're having in the comments below. So this is the search a 2D matrix problem. As we can see, uh, the numbers in this matrix are sorted. So 1, 3, 5, 7, 10, 11, and so on, which means we can actually use binary search for this. So binary search reduces the runtime to search an array by so we go from big O of n to big O of log n, and basically all we do is we search only half of the array in each iteration. So it searches only half of the array each time. Super efficient. So to do that, we'll just compare the element that we're looking for against the element in the middle of the array. If that's not the element that we're looking for, and the target element is actually larger than the element in the middle of the array, we search only half. We search the second half, of the array, and if that's not the case, we search the first half of the array, and we repeat this until we find the element that we're looking for in the array, assuming that it does exist in the array. So the runtime for this is big O of log m times n, if we're using it on a 2D matrix. Let's have a look at this description. Write an efficient algorithm that searches for a value in an m times n matrix. This matrix has the following properties. The integers in each row are sorted from left to right. The integer of each row is greater than the last integer of the previous row. So as we said before, the matrix is a sorted matrix, which means we can use binary search to find the array that we want. So in this case, the target number is 3. So we would use binary search and find this array as 3 is greater than the first element here and less than this element. Here we would basically, if we want using the search and searching through the first element, we would find this array. So the target is 13. 13 is less than 10 and greater than 23. Still return false because doesn't exist. 13 doesn't exist in this matrix. We'll start by writing a binary search method to find the element we're looking for in an array. So here becomes binary search. So just now we set the boundaries, so high and low, and the mid variable, which we're going to set now, which would be the variable that we'll be checking each time. So so now we've set the mid boundary, the mid value. So if we're going to check the mid value, if that is our element that we're looking for, then we'll just return true. So target. So now we're going to reduce the scope to the second half of the array, since the target element is larger than the element in the middle of the array in this statement. So node +1. Otherwise, we will search only the first half of the array. So high would be moved down to the middle, effectively searching the middle of the array. So now we're going to use binary search to find the array with, or we'll find an array that could potentially have a target element inside it. So binary search. So the same thing with the previous binary search. Yeah. So now we want to find the array. So we're going to look for the range of values, an array that would have the range of values that could potentially have the elements that we're looking for. So so just yes, less and high, and less than. So I'll just a quick comment here. So find or check all range of errors. So here we're just doing the same thing as the normal binary search in this case. So target. So here again we've reduced the scope to the latter half of the array. Pretty simple. So now we'll just check the base cases. So now we'll just call on the methods. So we want to find the array that could potentially have our target elements. Once we have that, we will perform a search, binary search on that array as well, and return true or false whether or not the array has our target integer or element. So let's check this out. If it works. Oh. So look. If you have any questions about this implementation or any suggestions about this implementation of binary search, leave it in the comments below. Otherwise, like, share, and subscribe for more content like this.